Welcome. This module covers the basics of boat stability, including influencing factors and what you can do to preserve boat stability and keep yourself and others safe on board. Sadly, a review of coronial inquests indicates a long history of boats capsizing in the Australian commercial fishing industry, often with loss of life. It is important to understand that fishing boats may still become unstable and capsize even if it has satisfied survey requirements and carries all the correct safety equipment, and even if the skipper has years of experience and a perfect safety record. To understand stability, it is essential to recognize that it is influenced by two forces. The first force is buoyancy, which pushes upwards all over the underwater part of the boat's hull. The total of these upward forces, called the center of buoyancy, can be represented as a single force acting through one point. The second force is gravity, which obviously acts downwards. The total weight of the boat and everything on board, including fishing gear, catch, fuel, stores, etc., contributes to this force, which can be represented as acting through one point called the center of gravity. Fundamentally, the boat will float as long as the gravitational forces are not collectively larger than the buoyancy forces. Now, as the vessel rolls to one side, the center of buoyancy moves towards the direction of roll. The part of the hull that has entered the water is now contributing to the buoyancy acting on the hull, while the part of the hull that has come out of the water is no longer contributing to this buoyancy. If the boat remains in this position, this is where the new center of buoyancy will remain. When the boat is upright in calm water, the center of buoyancy and gravity act along the centerline of the boat, and these forces are in balance. In a sense, these forces are said to be in equilibrium. Then, if the boat rolls to one side, the center of buoyancy moves to that side, but the center of gravity remains in place. These forces are now out of balance, and a righting lever attempts to return the boat to the upright position. If the boat rolls too far, the center of buoyancy may be unable to move any further. In this situation, the boat is now top-heavy, and the gravitational force will produce a capsizing lever and capsize the boat. Water on deck is a serious safety hazard. It can add substantial weight to the boat and introduce a significant rolling force due to the free surface effect of water washing from side to side as the boat rolls. The combined impact is to lower the freeboard of the boat, raise the center of gravity, and increase the risk of capsize. It is for this reason that scuppers and freeing ports must always be clear so that water can quickly leave the boat. Note that a loose catch on deck or in the hold can have the same impact on boat stability as water on deck. Other stability issues include accidental flooding of the boat. This can occur through valves and leaks in the engine space or downflooding through hatches, doors and vents. This causes the boat to sink lower in the water and reduce reserve buoyancy. The water can then introduce a free surface effect that attempts to capsize the boat. Shifting fishing gear. Fishing gear should be well secured and kept as low as possible when stowed on board. Unsecured fishing gear not only presents a hazard to those on deck, but it can affect boat stability. Hauling the catch. When the catch is hauled alongside and inboard, the center of gravity moves towards the block or lifting point holding the weight. As the catch is lifted out of the water, the weight of the entire catch is in effect transferred to this lifting point. This can cause the boat to list to one side, reduce freeboard, and reduce stability. Stabilizers. These are used to slow the rolling motion of the boat. When drop-down booms are in the stowed position, they raise the center of gravity. Towing fishing gear. When fishing gear is being towed, the center of gravity moves upwards and towards the towing blocks. This reduces the stability of the boat, particularly in heavy weather or if the boat is already heavily loaded. This can be a particular safety issue if the gear becomes hooked up on the seabed. A common response is to haul back over the gear in the hope that boat motion clears the snag. As this occurs, the boat may take in a lot of water. Wind and waves may cause the snag towing wires to slacken and tighten. This will subject the boat to large forces, potentially increasing the rolling motion and compromising stability. Spare gear and equipment. Over time the boat gets heavier because spare fishing gear and other equipment, including nets, chains, spare machinery parts, etc. are stored on board, all of which can also serve to compromise stability. A periodic clean out of the boat is a good way to overcome this issue. Finally, further information about fishing boat stability is provided in a manual produced by the Australian Maritime Safety Authority. This manual is available at www.amsa.gov.au. Congratulations! You have completed the stability module, so now it is time to answer a few questions.